So we're going to take a look at the very first one is just the concept of simplifying radicals. So we have to make a decision if something's in its simplest form or not, a simple thing. So actually we'll go through a couple of these and make a decision on it. So the very first one, we can start with the root of 24. So if we don't remember roots, we can do a little bit of testing of our own on the side. We can remember, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and then very quickly we get the 5 squared at 25, which is greater than 24, okay? So we know that our value needs to be between 4 and 5. So if we were trying to get an exact with a decimal, we can do something there. But another thing we can do, okay, so we know that we don't have a whole number solution, is we can break this into factors, and then we can see if we can find the roots of any of the factors. So a set of the factors could be, we know, like 4 and 6, okay? But one of the best ways to do it is actually take it to its prime factors and define sets of it. So this will work for anything. It's a little more tedious, but it does help a lot. So I'm going to open up, I'll actually go back here. I'm going to add a new page here. Let's say we have root 24, right? Think of the value of 24, and we're going to just break it down into prime factors. So we break it into prime factors, like we said, 4 and 6, okay? We'd have to find the roots of those. So we can keep calling them roots. Using this tree style actually becomes really helpful. And then we can break this down. Well, we know factors of 4 are 2 and 2, root 2 and root 2. And factors of 6 are root 2 and root 3, okay? So if we quickly take a look here, well, root 2 times root 2 is actually going to give us just the value of 2. So this can actually be simplified to one value, just the number 2. Here we can't really do anything with it. So to simplify it, we'd actually go back up a step. We'd say, oh, okay, we're going to go back to root 6. So to put this in radical form, 24, you can actually say the root of 24 is the equivalent of 2 times the root of 6 here. And that will give us the same value as whatever 24 is. And remember, think of this. It's 2 times root of 6 is probably 2 something, right? Some value. And the root of 24 we know is 4 something. So this kind of makes sense. 2 times 2 something is about 4 something. Yeah, in an approximation that actually makes sense. So we jump back. Our radical form, or to put this in radical form, would just to leave it as 2 root 6. Now you may have seen really quickly that, hey, I know the root of 4 is just 2, so you can kind of jump ahead with that one here. Let's jump over to E, okay? This already kind of looks like it's in radical form, but we should just focus on this value, the root 27, okay? Root 27, can I break it into what are factors of 27? So I'm going to open up a new page again, same concept. I'm going to talk about the number 27. Well, very quickly, some factors of 27. Well, I know I got 1 and 27, but that doesn't ever really work, right? What are other factors? 3 goes in, and 3 happens to go in 9 times. Now, I could break this down again, but I can instead this time see, oh, I know root 9 is just the value of 3. So I can rewrite this as the number 3. So this is actually going to be 3 times root 3. So when we rewrite it, we can say root 27 is the equivalent of 3 root 3. Now, when we go back, this is going to become a little different. We still have 3, but it's going to be times 3 root 3. So we actually still have to do a little bit of multiplication. 3 times 3, so this is actually going to be 9 root 3. So that's how we're going to put it into our radical form. And you can use that same concept throughout any of these. So you could do a bit of checking to see if something is a radical by breaking it into its prime factors or looking for anything that does have a square root to it. And if it doesn't go any farther, then you know it's already in its simplest form in those cases.